Chemistry. This is the answers video for day 74 calorimetry. We've done a number of these in class, so the front page is straight off the video. So I want you to go to the video and write down the steps of the calorimetry process. And the first problem is straight off the video. Okay, it starts at roughly minute 6:50. And I think that's still accurate, and I want you to just do that problem so that it actually has numbers to work with. So calorimetry is a way of measuring the temperature change, is having a reaction takes place of a system inside surroundings. Just think a system as being something dissolving like calcium chloride, and the heat from that reaction goes into the surroundings, which is the water and also the dissolved calcium chloride. That causes a temperature increase. The temperature goes up, and then using that temperature and the mass of the water and solution, that's the water and calcium chloride, and the specific heat of water, which we use to approximate the specific heat of the solution, that will give you the Q, the heat that's going into the solution. Okay, so again, watch the steps, follow them, understand them. If they still don't make sense, then ask me. Okay, so what I'm going to do here is I'm going to skip that. I'm going to go to the next problem. Now it's exactly identical as problem 2, but you have problem 2 on the video, so I'm going to go ahead and get started with this here. Okay, so step 1 is we're going to dissolve. Okay, so we're going to dissolve CaCl2 in water. Okay. Step 2 is okay, so as the calcium chloride dissolves, heat enters the surroundings. Okay, we cannot know how much heat that is. We don't have a way to measure heat, but we have a way to measure temperature. Okay, one thing we know is that the heat entering the surroundings. Okay, and I failed to define the system and the surroundings up here, so the system. There's the system, and the surroundings, I'll write it up here. Okay, so what we're studying is the chemical energy from the system, which is the chemical bonds of the CaCl2 being broken, and the ion dipole attraction of the water and the Ca2 plus and Cl1 minus ions. That wasn't explained that clearly in the video. Now what the surroundings is, which is absorbing the heat, is the water, the Ca2 plus ions, and the Cl minus ions. So in other words, the system is the bonds and the intermolecular forces. The surroundings is the substance. It's the physical substance of the water, the calcium, and the chlorine. Okay, so now I'm going to continue. Come on down here. Okay, and let's do this. Okay. And step 4 is to realize that the Q of the system, which is negative, the heat coming out of the system, that's a negative Q, equals the positive Q going into the surroundings. Okay, that might have been step 3 on the video. It's okay, it doesn't matter. So, all right, so, and we're going to use the formula. Okay, we can't measure the heat directly of the system, which is what we're interested in, so we have to do it indirectly. We measure the heat going into the surroundings, which is basically the water and the ions, and then we measure the temperature change. So we use the formula Q equals mc delta T. Okay, we need to use the mass of the solution, the specific heat of water, because we can't know the specific heat of the solution, and since most of the solution is water, we can use that. And then the change in temperature of the solution. So we're going to come on down here and do that. And we're given let's go ahead and write down the variables that we are given. The mass of the water is 450 milliliters, which is a volume, but that equals, in pure water, that's 450 grams. Again, this is not pure water, but we're using it as an approximation. Okay, so that's the mass of the solution. It's slightly more than that, but it's not really important. Okay, the C of water, and the delta T we had in the water was, it's given up here, has 5.29 degrees centigrade, which you can call degrees Kelvin. In fact, you could interchange Kelvin and centigrade here. I've explained why that is. If you don't understand, ask me. So that's 5.29. Okay, so that's what we're working with. So now we come over and plug it in. Okay, and we can cancel centigrade, centigrade, grams, grams, and we end up with joules. That's what we want. And so that number turns out to be. Okay, and that's the Q of the surroundings, and that equals 9,950. You can leave off the decimal points. That's already 4 significant figures. I'll leave it that. That's close enough. And that's joules. That's how much heat into the surroundings. Okay, so Q into surroundings. Okay, that means the Q of the system is the opposite of that. Negative 9950. That's how much came out of the chemical bonds and the intermolecular forces combined. Okay, now we want to know the molar heat. So we're going to set up, I'm going to do this as a single equation. So it's 9,950 joules. And where did that heat all come from? What mass? It came from the 3.42 grams, not from the water. We're not using the mass of the surroundings anymore. We're only using the mass of the calcium chloride because that's where the energy came from. Then we're going to take that and we're going to multiply by the molar mass because we want to get moles, not grams. We want moles to work with. Okay, and 1 mole of calcium chloride is 110.98 grams, so we're going to put moles on the top. Put grams on the top over 1 mole of calcium chloride. That's what we're dealing with here. Grams cancels, and now we have joules per mole. And now if we want to go to kilojoules per mole, we say 1 kilojoule. Put this all in one equation. You don't have to, but that's the proper way to do it. Equals 1,000 joules. So joules cancels with joules. So now we're going to multiply this and get our final answer. Okay, and that I'd come out with 322.9 kilojoules, and it's per mole, Okay, so that's your final answer right there in the corner, and I'm going to let you go ahead and do 4 by yourself. It's exactly the same substance we used in the lab, which is sodium hydroxide, and if you have questions, ask me in class or in tutoring.